Welcome to Numeracy module number 1. And look, I just say that we've got to break down this barrier that I think is a mindset, and students have it a lot, that math is hard. Well, it's not. It's only got 10 numbers and there's 26 letters in the alphabet, so it's obviously got to be 2.5 times or even better than English. Figure that. So let's have a look at mathematics. So this unit that we're looking at in module 1 is about number, fractions and percentages. So let's see what we'll find today. So placing the largest to the smallest. I'll give you a couple of seconds to have a look at that. Oh, there's some negative numbers, so we've got to think number line now. And would it help if I did this? Yes, it would. So let's have a look. We've got two negatives, so we'll put them over to the left. Now, which is the larger negative? The third number, negative 0.701, and it's 0.7, and the negative is a 0.1. So I'm going to put far left is 0.7. Second left is going to be negative 0.107. Now I've come to 0, and I'm just going to say which one is just a nudge over 0 and which one's a bit more over it. Well, the nudge over is the one that's got 0071. It's just a nudge more than 0, and to the right of 0, and 7 is 7 parts to the 0. So, you know, the order would be, so let's go to the next slide and see if we can look at that visually. There's 0 in the middle, and I have almost 7 to the left is the negative 7, and 7 to the right is positive 7. And a little bit from 0 would be the 0071 to 71 thousandths. Now, what makes this work is your understanding of place value, where the first digit here, oh, wrong, well, let's go backwards. The first digit here is 1 whole, 1/10, 1/100th, 1,000th, and 1/10,000th. And to also recognize that that's 71 thousandths of a number, and so on. So knowing place value helps you to organize information. So that's the first thing about that you have to have a really profound understanding of place value, and you'll teach your students really clearly what place value is about. I'll put a math starter on there, and I'm encouraging you to click onto this and do some practices. So here's a nice little one. You can mix up your numbers, because you've got to be confident and capable of doing these things really, really well. And this is a maths mentals, so it's something that you might have to do in your head. So this is a new one. Let's go for there. Going back, my PowerPoint won't let me, but here we go. Let's pull that up as a website. So I encourage you to try it. And let's pull it across here. So I'm going to do mix 4. There you go. And here's my question. Now, what's my number here? Well, place value. I've got 250, 2 100s, 5 10s, and 0. And I've got a 95. What would I do there? In my head, I don't know about you, I'm going to add 100. So that's 350 and take 5 off. So I'm going to go 345. So where's my answer? How do I type in my answer? It's not letting me. 345. Well, let's show. Not sure why it's not showing the answer. That's a great demonstration, Peter, isn't it? So show question and so on. So here's all the quizzes that you can test yourself at the end. Try that. There is an answer. I'm not sure why it's not working for us today. I'll probably need to sign in. So you can do that. I encourage you to have that as a bit of a check along the way and use that website. You'll find it quite beneficial. Let's go for some more now. What else have we got? Okay. How can you find the area of this? Now, you're not allowed to use multiplication. You've got to think like a computer, because a computer cannot multiply or divide or do anything else. It can only do two things. Well, if you've got the answers 41, you're right. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 across, and 4. 4 11 is 41. There you go. But that's multiplication. So what is multiplication? Well, it's actually 11 plus 11 plus 11 plus 11. And that's what a computer does, or a calculator does. Any digital device only has is only bimodal, 0 or 1. So it's actually saying, let's do this 11 thing 4 times. You go plus, 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 and multiplication is minus, because how many pluses can I fit in, sort of working in reverse. So multiplication is actually just addition. Why am I getting you to do that? I want you to think differently about maths. Why don't we think about how can I solve things? Just like my example previously, add 100 of them, take 5. Rather than add the 5, and then the next column add the 9 and the 5 and the 2 and carry 1 and carry 2, etc. Think creatively. Get your students to think creatively. Maths is manipulating numbers, organising numbers, playing with numbers. And there's no right or wrong way necessarily to do it if it works. As long as you understand what you're doing, the concepts are correct, and it works, then I'm saying go for it. Let's have a look at this one. Can you find the answer without a calculator? Describe your process in words. I'm going to give you a little bit of chance to reflect. Okay, the answer is 880. But how did you do it? Did you write it down and started to go 2 times 0 is 0, 2 times 4 is 8, etc.? What did you do? How can you describe this in words? Often you might have said, well, it's 2 lots of 40, that's an 80. I'll put that over the side there. And 2 lots of 40, that's an 80, but it's 20, so I'll put an extra 0 on, 800. I'll add those two things together. So it's 80 and 800, 880. Now, some of you will do the 2 times 40 first, but some of you actually go 2 times the 10 column first. 2 times 20 times 40, 80 first. So I challenge you that some students will actually understand multiplication better if you start with the larger number. Try it. Try doing it the other way around, and even make your setting out the other way around. And I think you'll find it works, and for some students, and perhaps yourself, you'll find it easy to do. What are we doing? We're playing around with these basic operations, which is the goal of this unit. Okay, so if you had a bit of paper and you've got a paper, you cut it in half. We'll put it one whole paper, draw a line through the middle. You've got half. And you've got to divide it by a quarter. The answer is 2. Students get really tricked up on this. How do you go with that? How would you describe that maths sentence in words? Well, in words, I look at it this way. How many quarters can I fit into a half? Oh, 2. So divide is almost how much I can fit in. Whereas multiply how many times I can go outwards, it's now squashing it back in. And that's what a computer does when it does divide, by the way. Now, you might have learned quite correctly that the little sneaky trick on this is invert and multiply. So get a half, invert it, and multiply. So then you get 4 on the top line and 2 on the bottom. You make that, simplify that to 2. Good, well done. But if you had to do it in your head, get a half and have a quarter and say, how many quarters can I fit in this half? The answer's 2. That's conceptually what dividing is. It's how much you can fit, how much you can divide or dissect into 4 ways, or the other way is how many quarters you can fit in. Interesting, isn't it? So I'm going to give you some time. How about you pause the video now and see how close, or can you get exactly 327 only using those numbers. Now you can use any operation, mathematical principle you go. So just do a pause, see how you go. Here's what other people did. I wrote them down from last time we ran this unit. So let's see what they came up with. How did they solve that? Well, the first one was doing that. Let's see if that works. 5 squared, 25 times 8, oh, that's 200. So 2 lots of 200. Beautiful. Minus, okay, 8 squared is 64 plus 8 plus 1, that's plus 9. So, I don't know if that works, does it? I don't think it works. 68 plus 9, so 64 plus 9, 73. So take away 73 from 200. That's not going to work. It should have been 400, shouldn't it? So, okay, because 73, 27, 73 makes the 400. So I think we made a little bit of an error. It should be 2 squared, shouldn't it? Outside the first bracket. Oh, well, there's a mistake. This one here, another one. 5 squared, 25 times 3 is 5 cubed, 125, times 3, that's 375, and you take off 50 there and add 2 on. I don't know how I can't do it in my head right now. I haven't done time. See what you got. But you can have, there's another one. I love the fraction, the vinculum. The vinculum, the line underneath between the denominator and the numerator. So it's shorthand for divide. Okay, so it's everything on the top divided by 2. Now brackets are like bomb dash, you might have thought, or mod dash, this and another one. You do the brackets first. So everything inside the brackets is its own little entity. Mass is great like that. So looking at the bottom one, that's 7 times, 10 squared. Okay, divided by 2, that's 3. There we are. And minus, and you've got 2 brackets going on there. Someone missed one over here. So you can do multiple ways. Now, it's a great little activity that you can get your kids to do in class. What does this mean? There's more than one way of solving this. There's no right answer, and kids get hooked up on how do I set it out perfectly, what's the right way of doing it, and they're more about learning the mechanics rather than the thinking involved. Now, some of the thinking involved that you might have had here was, how am I going to make this work? Well, let's get 300 and then add 27 on somehow. Well, let's get 400 and take 73 off. Well, let's get 350 and somehow subtract 23. Or let's get 320 and then add 7 on. So all those combinations are valid examples of how to do that. So get your kids doing that, playing with maths, playing with numbers, and they'll become just confident without even realizing and overcome that big maths block that you have. And one of the core areas here that we're looking at is fractions, decimals, percentages. Well, here's the secret. They are exactly the same thing. I'll say it again. They're exactly the same thing. You have the answer to the life, universe, and everything. That's 42. But it's just a different way of writing the same thing. So 1 over 1 is a whole, and it's expressed as a decimal as 1.00, or it could be 1.0. You don't need the second zero. I put it there to see if you can get a pattern. And the percent is 100%. It's 100 hundredths. And percent, hence century, centi, it's got that concept of 100 in it in the word itself. So can you see some patterns? Hope you can see the patterns here. Oh, go back. That the 100 there, 100 there, 20 there, 20 there, 10 there, 10 there. That the decimals align with how many hundredths there are. There are 100 hundredths, there's 20 hundredths, and 10 hundredths. They're all the same thing. Hope you've also noticed another pattern. 5 times 20, that equals 100. 1 times, 1 times 100 is 100. So what will be 1/3? Well, that's divided by 3. It'll be 0.33. And a half will be 2 lots of 50, 0.50. So hopefully you get to see the patterns. Well, this is what you want to get established within your students, that these simple patterns, they get to say, oh, well, really, a half is just 0.5 and 50%. They are all the same thing. So understanding those patterns will help the child when they see a problem to say, 25. Oh, that's 20 plus 5, that's 30. The minus 5, that's 5 squared, etc. They'll see those patterns and they say 25, oh, that's a quarter. Could have something to do with a quarter. Oh, that's 25%. All those things mean something for them when they look at numbers. And hopefully get really good. Like, what's 1/8? That's 12.5%. So when someone says on the TV, oh, it's 12% rise, you say, oh, that's about 1/8 less. Okay. So you're getting that literacy in mathematics. Let's see what else we got. Fractions. Oh, goodness me. We get so tied up with fractions, and look, seriously, we use calculators. And so let's not overdo the fractions, but you need to have an understanding what that is. So the first one is a half plus 2/3. And if you have a look at that, first of all, get the child to think, what is a reasonable answer? Is it more or less than 1 for starters? So let's have a look at what I've done here. Oh my goodness, look at this. That is the maths teacher's bane of their life. There's a half and there's 2/3. So if you put those two together, it's going to be more than 1, isn't it? Well, let's have a look what happened in the middle one here. What has the student done? They've added the top and they've added the bottom. There's a half, there's my 2/3. That's what it really looks like. And they're saying 3/5, which is less than 1, isn't it? So that's not a reasonable answer. So train your students to say, what's a reasonable answer? And you will, thou shall not. Okay, let's go back. Thou shall never, hand on heart please, never add together the top line and add them together on the bottom line of fractions unless they're the same type of fraction. Apples with apples, orange with oranges. So we have to get them to be the same sort of fraction before we can ever add them together. We will never forget. Sound like Winston Churchill. Anyway, going across, so how would we actually solve it in the mechanics? We know the answer is 1 and a bit. You know, I don't know, a third bit, a quarter bit, something like that. So let's have a look. Well, first of all, we've got to make them equivalent fractions. So half, what is the common number? Easiest one is to multiply the two together, but sometimes you can get them smaller than multiplying together. 2 to 3 is 6s. Okay, let's make a half into 3 6s. So teaching equivalent fractions, that's another process in itself. 2/3 is 4 6s. They're both 6s. We've both got oranges, so we can add the oranges together. What's the next step? We now have 7 6s. So that's 1 and 1/6. So it's 1 and a bit. The bit was 1/6. Okay, that we had. So thou shalt never add up unless they are exactly the same sort of fractions. That is, the denominator is equivalent, and you've done equivalent fractions. So with that, lowest common multiple or lowest common denominator is the old one you might have heard when you're adding plus or minus operationally. Now fractions which multiply are so easy, the easiest things on the planet. Okay, what do we happen there? We don't do this. We don't add them. That's pretty obvious, isn't it? We multiply them. So let's go on and say we never add fraction lines. No, never. That's right, never. Okay, yeah, correct. We don't do that. So how do I look at this? What's a quarter of a 2? See, in this sort of scenario, what's that represent in a grammar, sort of a sentence? It's a quarter of 2. So if you've got 2, you have to break it up into a quarter. That's 4 bits. So what 4 bits of 2 will you have? You know the answer is, okay, so how many, or flip it the other way around, I divide 2 by 4. So what's the answer? Hopefully you've got worked out. Here we go. Visually, let's do it. So use all those tricks in multiply and divide. So we have a quarter. There they are. So how many are there? You flip. What happened there? I'm not sure what I've done there. A quarter of 2, or chop into 2 blocks into 4 parts, and we're having that. So a quarter of 2 is a half. Is that right? Good with that? Okay. So there's 4 lots of half there. So there's 2 holes here. Beautiful. We've already talked about you flip and multiply is the process that we can do in terms of dividing by fractions. I'm not going to go into that, and here's an example. Of course, we never add half or something, which is fine. Okay, so what do? We have 3 divided by a half. How do we think that, how does that work? It is, how many halves can I fit into 3? That's half, I get 2 halves and 1, so therefore this must be 6 is the answer. So get them to think about that. So there we go. There's, not sure what I've done there. Whereas I think I have a box that didn't show up there. That's another 2 lots of half. Apologise for that. There's 6 of the halves there showing. There you go. So there's 6 halves. Yep, 6 is the answer. So percentage problems is the last area, and this is the key concept. The whole equals 100%, which equals 1.0, or 1.00 if using 2 decimal places. So an example is the whole fridge is 100%. Any object, the whole person, the whole amount of money, the whole house, the whole whatever, the universe, the whole thing's 100%. That's it. That's the core concept. And if you step off that concept, you'll be able to solve maths. Here's the problem. When you've got sort of another real problem, get the students and yourself to circle the key bits of information. So this problem, I'm going to read it with blah blah language. Blah blah, $520. Blah 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 blah, 20% discount. Blah blah blah. What's the cost? It could be fridge, it could be Apple, it could be encyclopedia, it could be a car, it doesn't matter, they're all the same. So the object just changes. So get them to circle 520, get them to circle 20%, get them to circle discount. They're the only key bits of information here that are of any meaning mathematically anyway. So how do we work that out? Hopefully you might have worked out in your head already. So let's see what they are. So the first one is 20% off means 80% left. That's one way of thinking about it. So therefore my decimal is 0.80. Okay, so what does that look mathematically? So method number one, my sale price equals 0.8 of the original price. Because I took off 20%. I minus 20% and then I multiplied. And I did 0.8 times 520, $416 is the answer. Is there another way? Another way of looking at it is 20% off, that's 0.2. So I can either, in the first one, took the percent off and then I multiplied. This time I'm going to multiply the 20% and then take off. So you're just doing the two operations separately. The discount's 0.2 of the original price, 0.2, $104. And I take $104 off 520, I get $416. So which is the right way? Answer, both are right. Both are right. Now, one question might not be asking what's the final price. The question might be asking what's your discount. So understanding what the question is asking is also important to the literacy of mathematics. So here's another one. So let's try that again. Numbers the whole, the same concept. So this time I've just got blah blah. I've just put a different blah blah in there. And this time it's a weightlifter. So the weightlifter's bulked up. They've increased now their weight by 17% in 3 weeks. Originally they weighed 112 kilograms. What's the new weight? What's your thinking here? 100% is the whole. They've got more. Is it more than 100% now? Oh, yeah, it was. It was. Okay. So my thinking might be 17% more, therefore it's 117%. I can write that as a decimal, 1.17. That's one way of doing it. The second one might be 70% more. I can do 17% of the weight and then add it on at the end. This is the other way of doing it, 0.17 of the weight. So what's the answer? There's your two answers. So method number one, 1.17 times the weight. Other one is 0.17 times the weight, and then add that answer on to 112. Both will equal the same answer. Which one's right? They're both right, because you can do it either way. And what is the question answering? Is asking you, make sure you understand what that is before the student progresses on the problem. And also to have a look at the answer. Now, the answer 131, and they started at 112. Well, that's more, isn't it? Okay, so that's reasonable. It's reasonable that if they had an answer, less, well, that would be unreasonable. Or they had an answer that was like 115, just a little bit more. Now, if they understand 17%, then they have an understanding. Well, how do I work out what sort of fraction is 17%? Is it half? No, it's certainly a lot less than half, isn't it? Well, how do we work that out? Remember, 2 times 50 is 100, so half is 0.5. So 17 into 100, how many times does that go? Okay, so it goes about 6 times. So 17% means about 1/6 more. So if I'm starting with 100 and something, then I'm going to have 1/6 more. Or another way of looking at that is 17% is 17 in 100. So if it's just a bit more than 100, he's going to go up a bit more than 17, isn't he? Okay, so use those knowledge of how decimals equals percentage equals fractions to establish in the child what a reasonable answer is, and they should be expecting around that 130, and they do. They say, oh, that's a good answer. It's or otherwise you'll get the child say the calculator says it's right, therefore it must be right. No, the calculator doesn't think. The calculator just does the computation. So thinking is invested in the learning. So hopefully you have those there, the key things. Now I'm going to send you off to back to the Moodle page, and you can do a quick review of what your strengths and weaknesses are in terms of number, in terms of fraction and percentages, and then problem solving with percentages, and have a look at those things. So enjoy your maths.